Okay, good morning everybody. I am back from quarantine, so I'm in my classroom again. That's kind of nice. So if you need to see me, come see me. Just wear a mask and stay 6 feet away. Well, today is Monday. Actually, it's Friday because I'm recording this early, but that's okay. 12/7 because I just want to get it done. So let's take a back step to something that we hopefully learned in algebra. We did a little bit of geometry in algebra, and that is about parallel line theorems, okay? So to do that, let me go ahead and draw a couple of parallel lines here. Okay. And if I have a couple of parallel lines, let's call this line L and line M. And we can say that L is parallel to M, okay? So then I'm going to draw what we call a transversal down the middle of these. Call that T for transversal. You don't have to remember that specifically. But last year, hopefully, we learned about a thing called corresponding angles. And the corresponding angles makes that F. I don't know if you remember this or not, but the corresponding angles make the F, okay? And so what's hopefully obvious to you is that corresponding angles are equal. So you can see that that angle there is going to be equal to that angle there. Or vice versa. You can do it upside down F. That angle is equal to that angle. Or vice versa. That angle is equal to that angle. Okay, these are called corresponding angles, and corresponding angles are congruent. Okay, makes the symbol F. You can see there and there. Okay. Now alternate interior angles, just like the word says, they are angles that are in the interior. Let's get some parallel lines. There we go. Oh, it doesn't look too parallel, but use your imagination. So alternate interior angles are going to be like here and here, because they alternate between the transversal and they alternate and they're on the interior. So there's an alternate interior angle. Makes a Z. See the Z pattern? Okay. Now there's also makes a Z. There's alternate exterior angles, and I'll use the same figure for those. So those are on the exterior, let's say outside, like that and that. And you can see that alternate exterior angles will also be equal or congruent. Okay, so there and there. They are both on the alternate. They alternate from one side to the other side of the transversal, but they're on the outside. Okay. Same side supplementary doesn't make them equal, but supplementary. Supplementary means 180 degrees. It means they add. They add to 180 degrees. Okay, so if I do that real quickly, boom, and boom, and draw my transversal in. So same side supplementary means like this angle here and this angle here. Okay, they don't look equal, do they? They don't look equal, but they will add it to 180. For example, let's say it's 120. This would be 60. Okay. Same side supplementary. And finally, vertical angles. Vertical angles don't really have to do with parallel lines at all, but if two lines cross, then the angles opposite are equal. Those are vertical angles. See the V? It looks like a V, doesn't it, for vertical? There's even. Check it out. You probably saw this. So, hey, Mr. Davies, what about that one and that one? Yes, those are vertical angles also. Okay, knowing that, let's move into our lesson for today, okay? So, angle similarity theorem. Okay, so today we're going to be proving, today's objective is to prove that two triangles are similar. Okay, similar. Not the same shape, but the same size. Not same size, am I saying this backwards? Not the same size, same shape, okay? Same shape. Different size, possibly. Different size, but same shape. Okay, so if that's the case, if they have the same shape, then their angles should be equal. So we have this thing called the angle. So if two angles of one triangle are congruent to two angles of another triangle, then they not equal, not congruent, they are similar. Now the thing about it, it just makes obvious sense to me. It isn't called angle, 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 because if you get 2, you automatically get the third, right? You only need 2 because it'll force the third. So you don't really need the third angle because it's going to always happen, okay? So let's take a look. Example 1. Let's show it, okay? So it says they're similar, okay? And so let me go ahead to make this easier, and let's draw out the 2 triangles. I'm going to take them apart because there are 2 triangles here. I've got triangle ADC, right? And this angle's 52 degrees. So I just drew the big one, okay? And let's draw the little one. So the little one is right there. Draw the little one out. Let's draw the little one. And I got a 52 there also, right? So I do know this. Angles, those 2 angles are equal, but I need one more. They share angle A. So I know angle A is also equal. To show this, if I want to show it, I can say then that angle A is equal to angle A. All right, we know that. You can use this symbol congruent, okay? So now I have angle, angle. So I can say yes by angle, angle, similarity, okay? Because I've got the 2 angles, 52, 52, and angle A to angle A, okay? All right. Well, B. Gosh, if I look at B, there's nothing. But wait a minute. We just learned something about parallel lines. Parallel lines. Oh, looks like I might have a Z going on. Let's take a look at this, okay? So if I take a look at parallel lines, I have a Z right there. There's my alternate interior angles. So I got to show it, right? I need to show this. So here's what I know. Angle R is congruent to angle U. So I'm going to mark that. Up, angle S. Come on, Mr. Davies. Angle S is congruent to angle U, and at the same time, the Z goes the other way. And I also have angle R congruent to angle T. Oh, I also have the vertical angles, but of course. So I can also say that angle R is congruent to angle T. I just needed 2 angles, so I can say yes. So I showed it. Remember, see how I showed it? Yes. By angle, angle, similarity. Okay, so all you have to do is this. The goal is to find 2 angles that are equal to the other 2 angles. That's our goal, to find 2 angles that are equal to the 2 angles of the other triangle. Okay, so let's take a look at number 2. So the hard part is that it's just, there are 2 triangles here. Let's take a look at what I have. So I've got a triangle here, and then I got another triangle here. Okay, so to make it easier for me, oftentimes what I do is I will just rewrite them. Okay, so I'm just going to redraw them. So I'm going to redraw this one right here. And I'm not much of an artist, but go along with me. F, C, and D. And I know that this is 32 degrees, and that's 90, right? Okay, let me take this one here, and I'm going to have to flip it around and draw it. I like to draw them so that they're in the same orientation. So I'm going to take this little one here. I'm going to draw it out, okay? This is my triangle FED like this. So I'm going to have my D here, my F here, and my E up here, okay? Now this is 58 degrees, and that's also 90. So what I know is in any triangle, it's going to add up to 180 degrees. So if I subtract out the 90 and subtract out the 32, let's see what I get, right? Because I'm trying to find that angle right there. Hopefully it's going to be 58. If it is, then I've shown it, right? So, okay, so glow batteries, okay. 180 minus 90 minus 32, and I get an answer of 58. Sure enough, I've got it. So I know that angle D is congruent to angle E, and I know angle F is congruent to angle F, and I also know that's got to be 32 from the same reason, okay? So I can say yes, because I got to show it. I can say yes by angle similarity. So that's like you got to say y, and the reason why is by the two angles. So we've got to find two angles, okay? Okay, now, what do I have? Well, I have parallel lines on this last one, okay? So I can do the alternate interangles, parallel lines. I can do the z. Let's see if I can find a z. So if I take a look and I find a z right here, I have that angle is congruent to that angle, okay? So I can say right off the bat that I know that angle PQS is going to be congruent to angle RSQ. Okay, now I get another set of parallel lines. Check this out, okay? So if I go like this, there's another Z, and so I can say, well, here's my other Z, and I can say that angle RQS, that's that angle there, RQS is congruent to angle PSQ. Okay, so I've got the two angles. So I can say yes. And the reason is because of this theorem called angle similarity. Okay, so I've shown it. I found the two angles. They're equal. Okay, all right. Now, let's take a look at the second page. Okay. All right, so now, example 3. Let's graph it, okay? So 5, 10. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there is A. 5, 6. 1, 2, 3, 4, 5. 1, 2, 4, 5, 6. Okay, there's B. C is 2. 1, 2, 3, 4, 5, 6, 7, 8. There's C, okay? So there's one triangle. Okay, I'm just going to go ahead and make that a different color so I can see it, okay? Okay, now I'm going to have another triangle. Let's see if I can graph that. On the same grid, graph triangle AE. Now A is already part of it. Okay, we're gonna remember that. AED, where E is -1, 6. 1, 2, 3, 4, 5, 6. And D is 5, 1, 2, 3, 4, 5, 1, 2. Okay, so let me draw that in a different color so we can see them both, okay? Okay, now find the slopes of CB and ED. Okay, slopes of CB, slope of CB. Okay, I'm just going to count, right? CB, oh, hold on, I forgot to put this D here and E here, okay? CB, so slope is down 2 over 3, right? And find the slope of ED. Let's see, it's down 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Down 4 over 6, but that does reduce to -2/3, okay? So, here's what I know. If the slopes are the same, remember slope is rise over run. If the slope's the same, then they've got to be parallel. So here's what I know. I know CB is parallel, that's symbol for parallel, to ED. It's got to be. Okay, if that's the case, then I know that this angle is equal to that angle. Okay, they're corresponding angles. See the F? We talked about corresponding angles. I also know they both share angle A, right? So that's another one. And I also know that this angle here is equal to that angle there because of the parallel line. So, show the two triangles similar. I just did. And so they is yes by my angle similarity. Okay, we'll talk about this more when we do our Zoom. I'll talk to you soon. Bye, guys.